Hey guys, Mr. Palmer back with another acid-base type problem, looking at acid-base equilibrium. This one's looks at using a basic salt or an acid salt, and how do we find the pH? How do we do these kinds of calculations? So again, this is one. Try it on your own, see how you do with it. It's got a lot to it here, and then come back and follow through the explanation of the content. Okay, so let's hop in this case. You're given benzoic acid, a weak acid. They get told the Ka, and you have sodium benzoate, which is a preservative used in acidic foods. They're giving you a molar mass of it, and we're going to be looking at this kind of buffering type solution and an acid-base solution. So it asks you to write the balanced equation for the hydrolysis, Ka, Kb calculation. So let's work our way through. Starting at the beginning, write the balanced chemical equation for the hydrolysis reaction that occurs between benzoate ion and water. Benzoate ion is the C6H5COO minus, right? That's coming from the sodium benzoate. Let me switch my colors here. We're going to be reacting that with water. The sodium benzoate is going to react as a conjugate base of the benzoic acid, right? So it's going to pick up the hydrogen from water, and it's going to turn back into our benzoic acid, C6H5COOH, and it's going to give us a hydroxide. That's how it's acting as a base. So our conjugate base turns back into our original parent weak acid. Okay, pretty straightforward. Probably like a 1-point problem. Write the base equilibrium Kb. So you're taking the balanced chemical equation. We're going to get a Kb expression for it. Well, remember, Kb is our, if I go back to my equation, the acid times the hydroxide, right? It's our product over our base, rather our weak conjugate base. So that's going to be our acid. That's the C6H5COOH times the hydroxide ion concentration over that conjugate base, C6H5COO minus. I'd say again, that's like a 1-point type problem, just writing it correctly. This next part B, this next part C asks us to calculate the base equilibrium constant. Well, we don't have any concentration values or anything. This is coming from the Ka that's given to us in the prompt. For any acid-base pair, the Ka times the Kb is going to give us the Kw, right? Or 10 to the negative 14th. So we were told that the Ka is 6.25 times 10 to the negative 5th times the Kb. So when we divide, that's going to give us 1.60 times 10 to the negative 10th. And remember our relationship we said. The bigger the Ka, the smaller the Kb of the conjugate is going to be. Part D, we'll just do this last part for the first part of this review. It says a beverage contains 0.1 grams of this sodium benzoate per 100 mils. Calculate the initial concentration of the ion in the beverage solution, assuming the density of solution is 1 gram. Well, we don't really need all of that information. All we need to know is we have 1 gram of this stuff, or 0.1 grams of NaC6H5COO per 100 mils, right? That's enough to get a concentration. We need to convert our milliliters, right? 1,000 milliliters is 1 liter. So we got our milliliters into liters, and we're going to take our grams into moles. All we need is the molar mass, and we were told that, which is 144.10 grams for every 1 mole. That's going to give you 6.94 times 10 to the negative 3rd molar for a concentration. And I would say it's probably a 2-point problem, one for the correct setup here in the problem, and one for our correct answer. Okay, I'll be back to finish up the remaining parts of this with pH.